Edmond Halley, an English astronomer and mathematician who was the first to calculate the orbit of a comet, later named after him. He is also noted for his role in the publication of Isaac Newton's Philosophiae Naturalis Principia Mathematica. Halley began his education at St. Paul's School in London. He had the good fortune to live through a period of scientific revolution that established the basis of modern thought. He was 4 years old when the monarchy was restored under Second Charles. 2 years later, the new monarch granted a charter to the informal organization of natural philosophers, originally called the Invisible College, which then became known officially as the Royal Society of London. Halley entered Queen's College in Oxford in 1673 and there was introduced by letter to John Flamsteed, who was appointed Astronomer Royal in 1676. On one or two occasions, Halley visited the Royal Greenwich Observatory where Flamsteed did his work, and there was encouraged to study astronomy. Influenced by Flamsteed's project of using the telescope to compile an accurate catalogue of northern stars, Halley proposed to do the same for the southern hemisphere. With financial assistance from his father and from King Charles II, and introduction to the East India Company, he sailed in November 1676 in a ship of that company, having left Oxford without his degree, for the island of St. Helena, the southernmost territory under British rule in the South Atlantic. Bad weather frustrated his full expectations, but when he embarked for home in January 1678, he had recorded the celestial longitudes and latitudes of 341 stars, observed a transit of Mercury across the sun's disk, made numerous pendulum observations, and noticed that some stars apparently had become fainted since their observation in antiquity. Halley's star catalogue, published late in 1678, was the first such work to be published containing telescopically determined locations of southern stars, and it established his reputation as an astronomer. In 1678, he was elected as a Fellow of Royal Society and with the intercession of the King was granted the MA degree from the University of Oxford. In 1684, Halley made his first visit to Isaac Newton in Cambridge, an event that led to his prominent role in the development of the theory of gravitation. Halley was the youngest of a trio of Royal Society members in London that included Robert Hooke, the inventor and microscopist, and Sir Christopher Wren, the famous architect, both of whom, with Newton at Cambridge, were attempting to find a mechanical explanation for planetary motion. Their problem was to determine what forces would keep a planet in forward motion around the sun without either flying off into space or falling into the sun. Since these men were dependent upon their scientific stature of both livelihood and sense of achievement, each had a personal interest in being the first to find a solution. This desire for a priority, a propelling motive in science, was the cause of much lively discussion and competition between them. Although Hooke and Halley has reasoned that the force keeping a planet in orbit must decrease as the inverse of the square of its distance from the sun, they were not able to deduce from his hypothesis a theoretical orbit that would match the observed planetary motions, despite the incentive of a prize offered by Wren. Halley then visited Newton, who told him he had already solved the problem. The orbit would be an ellipse, but that he may slide his calculations to prove it. Encouraged by Halley, Newton then expanded his studies on celestial mechanics into one of the greatest masterpieces produced by the mind of man, the Principia. The Royal Society decided Mr. Halley undertake the business of looking after it and printing at his own church, which he proceeded to do. He consulted with Newton, tactfully subdued a priority dispute between Newton and Hooke, edited the text of the Principia, wrote laudatory verse in Latin for the preface to honor its author, corrected the proofs and saw it through the press in 1687. Halley had the ability to reduce large amounts of data to a meaningful order. In 1686, his map of the world showing the distribution of prevailing winds over the oceans was the first meteorological chart to be published. His mortality tables for the city of Breslau in Germany, published in 1693, comprised one of the first attempts to relate mortality and age in a population. As such, it influenced the future development of actuarial tables in life insurance. In 1701, he published the first magnetic charts of the Atlantic Ocean and some of the Pacific Ocean, showing curved lines that indicated positions in the oceans having the same compass declination. These charts, compiled from all available observations and augmented by his own, were intended to be useful for navigation and perhaps to solve the great problem of determining the longitude at sea. However, because it was difficult to determine the compass declination with sufficient accuracy and because it was soon discovered that compass declination can vary from year to year, this method of finding longitude was never widely adopted. Notwithstanding opposition from Flamsteed, Halley in 1704 was appointed Savilian Professor of Geometry at Oxford. Continuing his pioneer work in observational astronomy, Halley published in 1705 a synopsis of the astronomy of comets, in which he described the parabolic orbits of 24 comets that had been observed from 1337 to 1698. He showed that the three historic comets of 1531, 1607 and 1682 were so similar in characteristics that they must have been successive returns of the same visitant, now known as Halley's Comet, and accurately predicted its return in 1758. Observing transits of Venus across the disk of the Sun, predicted for 1601 and 69, in order to determine accurately by solar parallax the distance of the Earth from the Sun. In 1718, by comparing recently observed star positions with data recorded in the ancient Greek astronomer Ptolemy Almagest, he found that Sirius and Arcturus had slightly shifted their positions with respect to the neighbors. This was the discovery of what modern astronomers call proper motion. In 1720, Halley succeeded Flamsteed as Astronomer Royal. Under the instructions from the Admiralty, he commanded the war sloop Paramore Pink in 1698 to 1700 on one of the first sea voyages undertaken for purely scientific purposes. This one to make measurements of the compass declination in the South Atlantic and to determine accurate latitudes and longitudes of its ports of call. In 1720, Halley succeeded Flamsteed as Astronomer Royal at Greenwich, where he made observations such as timing the transit of the moon across the meridian that he hoped would eventually be useful in determining longitude at sea. Halley's concern with practical applications of science, such as problems of navigation, reflects the influence on the Royal Society of British author Francis Bacon, who held that science should be for the relief of man's estate. Though wide-ranging in his interests, Halley displayed a high degree of professional competence that foreshadowed scientific specialization. His wise assessment of Newton's work and his persistence in guiding it to the completion earned for him an important place in the emergence of Western